Hi, I'm Surya Ravichandran. My teammate Madhesh and I worked on this project emulating Hadoop MapReduce as part of the DSCI551 project. I will first give you an overview of the things that were implemented and walk you through the code, and Madhesh will take over for the demo. So firstly, the components implemented. We have a file system, which is an emulation of the Hadoop file system. And then we have a mapper. This mapper maps data to key value pairs with user customizable functions. Then we have the data partitioner, which partitions the data from the mapper, a data shuffler, which merges the partitions from different mappers, a data grouper that sorts the merged data, a reducer that provides the desired output with user customizable functions again, and a job tracker which ensures the success of a task, and a task tracker that tracks and logs the ongoing tasks. So for the demo, we have the following configuration. The data set that is taken is that of goals and shots of different clubs in the English Premier League. The file system is the emulated HDFS on Firebase. The objective of this MapReduce is to find the maximum home and away goals. The mappers will be equal to the number of partitions in the data, and the reducers can be user defined, but in this case, we are going to take two. Quick description on the functions itself. Firstly, we have the mapper, which takes a function and it returns mapper files, basically key value pairs. Then we have a partitioner, which takes the mapper files and returns 2n files. Here, the 2 is the number of reducers. So the number of reducers times the data output of the mapper will be the output of this partitioner. Then we have the shuffler, which takes these 2n files and returns 2 files, which is equal to the number of reducers. And then we have the data grouper, which performs external sorting and returns the sorted files. And then we have the reducer, which takes the sorted files and also a function and gives the desired output. So I will give a walkthrough of the code. So firstly, we have the initialization, which basically loads the data from a CSV and then performs any imputations for missing values. And then we partition the data according to the team name. So each team is a particular partition. So these are then stored in Firebase. So after the initialization is done, we allow the user to input the number of reducers. So as part of this demo, we will be using 2 reducers, and then we go to the job tracker. So the job tracker takes over from here. So to the job tracker, we pass 2 arguments, which is a mapper and a reducer. So these are the user-defined functions, which I will explain shortly. So once we get to the job tracker function, it takes the map task and the reduce task as inputs. And then we have the loggers that basically, gives information as to what task is happening, which is basically the task tracker here. So the first task would be to start the map task, and which essentially happens after you call the mapper function. So the mapper takes the user-defined map task function. So let's go to the map task function first. So it's called the task2_mapper. Yeah. So the mapper function takes the data and the output file as the inputs along with the partition. And what it does is it partitions the it's supposed to store each team's goals, each team's home goals and away goals. So that is what is done by iterating through the partitioned data that is stored in the in each of the partitions. And then finally, we write back the updated values. So now the key value pairs will be the team name and the home goal scored and the away goal scored as two separate patches to the data. So once that is written, then the mapper will be called. So the mapper takes the function to run as input, which is basically here the mapper that the task to underscore mapper. Then we have partitions. So the partitions are basically the partition based on the team names, which is got by the ls command. Um, Again, this is the emulated HDFS that retrieves the data. And so then for each of the partition, we sort of create a thread. So each partition runs on a thread, which essentially means that we are going to have parallel processing here. And what's going to happen is it's going to call the task to underscore mapper, and it's going to get the partitions and store the home and away goals as the key value pairs. The key will be the team name, and the value will be the corresponding goal, corresponding number of goals. So once that is done, we go back to our job tracker. So after the mapper is completed, then we call the uh, we go to the partitioner. So the data partitioner is supposed to partition whatever the mapper outputs are there to the corresponding reducers it is supposed to go to. So we will go to the data partitioner function. So here in this function, we are going to have the mapper outputs path which is passed to this, and for each of the reducers we are going to have a list. So this is essentially a list of lists, and each partition is it's basically like the first half of the data is going to go into the first reducer, and second half is going to go to the second reducer. So accordingly, we have to partition these data values and write them back to the Firebase. So that is what is happening here. So after the reducer is done, we return back to our job tracker. So after the partitioning is completed, we go to the data shuffler. So in the data shuffler, what happens is we are supposed to uh, merge the separated data files as individual partitions. We have to merge it to just two files now. So merge all that is supposed to go into reducer one into one particular file, and merge every other thing that is supposed to go to the reducer two into another file, and write it back to the Firebase database in this case. So after the shuffling is done, we go back to the job tracker, and we are here. So in the data grouper, the data grouper collects opens these particular locations wherever the two files exist, and it's going to sort the data. So we have implemented an external sorting, which is going to in each of the files, it is going to um, take the values, take the keys, and sort it according to the keys. So each of the partitions are going to be sorted according to the keys, and written back to the Firebase here. And After that is done, we come back to the job tracker. Yeah, after the the sorting is done, then we go to the reducer file. We do begin the reducing task. So the reducer will take the the sorted files and perform the reduce task upon it. So we can now check out what is there in the reducer. So it is called as task2 underscore reducer, which is the user defined function here. So the task, as I mentioned earlier, was to find the maximum home and away goals. So that is what this is going to do. It is first of all going to retrieve the data, and then it's going to find the max value, and then it is going to store it back in the Firebase. So once the result is obtained, it is going to write it back to the right path. So that is the reducer task, and we have the function that is going to call it is the reducer function. So again, we have threading here. So each reducer is going to run on a particular thread, and thereby achieving parallel execution. And after that is done, after the reducer is done, we call the cleanup function, so which is just going to erase all of the temporary files that were created and leave only the reducer's outputs. So after the cleanup is done, we are good to go. We have the results which will be stored in the respective output paths. So that was the code walkthrough. We will now have Madhesh take over for the demo of this.
Hi, I'm Madhesh, and I'll be explaining you through the demo of our project. The title we had chosen was Emulating Hadoop MapReduce using Python, and we have established it with the help of Firebase as a data repository. So before going through the demo, I'll just quickly go through the dataset. So this is the dataset that we have chosen. So basically, this dataset contains all the details about every games held in the English Premier League over the last decade. So we have every details about each game, like which team scored, then the scores during the halftime and full time, and etc. So the idea here is to split this data into multiple partitions, which will be stored in different data nodes. Data nodes here would be each and every separate nodes in Firebase. Um, so the Firebase node is empty currently. We'll start populating it with our data. So the first step would be the data would be partitioned, and the partition data would be stored under each node in the uh, Firebase database. You can already see that the data whichever is being partitioned being populated inside the database. Great. So once that is done, the next step is defining a mapping and reducing functions. So the operation that we are trying to do is we are trying to find which team has scored the maximum home goals and which team has scored the maximum away goals. So basically, our map task is counting the number of home goals and away goals of each team, and our reduced task would be finding the maximum of those counts. So yes. So this is our function for the mapper, which basically counts the home goals and the sorry, which basically counts the home goals and the away goals. and our reducer would be finding the maximum of those. So we have implemented a function called mapper, which would run this mapper task in different partitions. So yeah, so we feed this mapper and the reducer functions into our mapper and reducer functions which have defined. And what those functions do is they essentially run all these mapper and reducer tasks in multiple nodes. The multiple nodes we say here would be established through threading. So by using parallel threads, all these processes will be processed in a parallel fashion. So essentially, we'll be having one thread per partition, which would basically serve as a an individual data node for them. So since each mapper would give us two outputs, the number of home goals and the number of away goals by that team, we would select the reducer as 2. Yeah. So once you give the input as 2, we call the job tracker. So job tracker is the master of all the mapping and reducing operations. So basically job tracker, it will communicate with the client and with the map reduce components, and it's the one which handles all the addresses and data transfer. So and that job tracker will call it onto the mapper function. Yeah. So our mapper has run all the, the counting task in all the nodes, and the result of each and every mapper output is stored again in the database, which we can see here. So for the node called Arsenal, we have the home and away goals counted. For Aston Villa, home and away goals counted. So this is done for every partition, and hence the mapping task is complete here. The next step would be the partitioner. So the partition, essentially what it does is it partitions the mapped output into different files so that it can be directly fed into a reducer. So if you have if you have a mapper output file, and if you have like two reducers, it essentially divides the output of the mapper into two so that it can be fed into different reducers. Again, this is also done in a parallel fashion. This runs on each data node, and here in Python we have established it using multi-threading. Yeah. So you can see the output of the data node Arsenal has been divided into two now. This would go into reducer 1, and this would go into reducer 2. The next step is shuffler. Shuffler, this clubs all the data that should go to reducer 1 and clubs all the data that should go to reducer 2. So at the end of shuffler, we'll be having two different files. One file which has the input to reducer 1, another file which has the input to reducer 2. Yes. So we have partition output of the which belongs to the reducer 1 is all clubbed here. Similarly, the partition output of reducer 2 are clubbed here. By the way, all these communications are being monitored by something called as a task tracker, which is a monitoring program which would keep an eye on all the tasks running and see if it is failing or if there is any errors with the issues. And this task tracker will again communicate back with the job tracker and keeps it updated regarding all the tasks. That is also implemented here. So once the shuffler is done, next step is grouper. Grouper basically it helps in sorting of the data. But since you're using Firebase naturally returns sorted data, which is so it's basically redundant here. But in case if if you're using some other database and if you want to do some word count, then sorting comes in handy. So here we have taken into assumption that the main memory is not enough to hold the whole of the data. Hence, for sorting, we use merge sort, which pulls each of the file and sorts within it and then merges at the end. So the group files are stored in the same location again, and then comes the reducer. So the output of the grouper 1 would go to reducer 1, and output of grouper 2 would go to reducer 2. And once the reducer is complete, you can see the teams which have scored the maximum away goals and maximum home goals. And cleanup is basically it would delete all the additional files created so that our database remains clean. So that is all about the demo of it.
So thank you, Madhesh. And finally, we have the next steps as part of this project. So we could use Docker to enable seamless scaling up of number of mappers and reducers, as in use real systems instead of just using threads. And then we can implement the job tracker using RabbitMQ. So RabbitMQ can be the orchestrator to manage the tasks. And we could also upgrade the existing file system implementation. Right now it is on Firebase, so we could upgrade it to a more native HDFS style system. So these are some of the things that we implemented and some things that we aim to implement in the future. And that's it from us. Thank you.